So this lesson is 19b. It's on the area between two curves. And first of all, we'll establish the way of doing it by drawing two curves. And say you have f up here, and then we'll draw kind of like the book did. Here's g of x underneath. And you want to find the area between those two curves, which would be this reader goes all the way down there. Okay. Well, first you would need to find the intersection of these. Call that a and b. And then the way to get the area would be the integral from a to b of the upper function f of x minus the lower function g of x dx. And the other way the book writes it is they could say from a to b, and then call f of x the upper function, so y sub u minus the lower function y sub l. Upper minus lower. And then there's a nice little geometric proof, so to speak. If you took the f and g and you translated them upward enough to where the entire region was in the first quadrant, like something like this. Here's f, and then let's just say we translate g so it's up here. And if we are just translating, then the area between those curves is identical. It doesn't change. And then you can see that if I was to go from a to b, and let's say I did the integral from a to b of f of x, that would be, we'll do this pink region, that would be everything under the curve f of x and the x-axis, so that would be that pink region. And then let's say I did the integral from a to b of g of x. That, I like yellow, so when I do yellow and pink it should kind of gray out, so let's do that. Let's do yellow and see what happens. So that'll be the area under the g, which is this curve right here. So if I do the pink area minus the yellow area, I'm obviously going to be left with the striped area, the shaded area there that I'm looking for. So that's why we are able to use these wonderful formulas right here. And that's going to bring us right into the first example. There are three examples, and actually the first one is really something similar to what we did in, well, we'll go ahead and do it. It's simple enough. It's a little more like the ones in the previous section. So example 4 says, find the area bounded by the x-axis by the x-axis and y equals x squared minus 2x. So just in case you are asked to do this by hand at some point, I'm going to do it by hand now. We know that x squared minus 2x is a parabola. We know that it opens up, and I need to figure out where the zeros are, so we'll set it equal to 0 and factor. So we get zeros of 0 and 2. And we do know it's opening up, so it looks something like that. And it's asking us to find the area between the x-axis and the curve. So it's just going to be simply the integral from 0 to 2, because this is 2, this is 0. And if I was to integrate from 0 to 2, I would get a negative value since I'm underneath the x-axis, but I want a positive value, so I need to negate it with a negative out front. Okay, we'll go ahead and integrate that. So there's a negative out front. X to the third over 3 minus x squared. Evaluate from 0 to 2. So I'll carry my negative along out front. 2 cubed 8 over 3 minus 4 minus, and thankfully 0, when we plug it in we just have 0, so we don't have to do much extra math there. So we've got 8 thirds minus 4. We need a common denominator of 3. 8 minus 4 is negative 12, or 8 minus 12 is negative 4 thirds, and then there's that negative out front, so lo and behold we do indeed get a positive area. and that's going to be units squared since it's an area. So first one wasn't too bad. Next example is example 5. This one will be a little more interesting. Find the area of the region. Find the area of the region bounded by, I am writing fast, y equals x plus 2 and y equals x squared plus x minus 2. So again, let's assume we would have to do this by hand and graph them by hand. Do that graph over here. The first one's a line. I'm going to try to graph them as carefully as I can so I can see where they meet. And the first one has a y-intercept of 2 and it has a slope of 1. So there's y equals x plus 2. And then the second one I have to factor to get my zeros. Positive 2 and negative 1. So x is negative 2 and positive 1, which is nice because here's negative 2, here's positive 1. I know this is a parabola. I know it's opening up. It happens to have a y-intercept of negative 2 also. And not only that, I know that the axis of symmetry is halfway between the zeros, so that would be right here at 1/2, negative 1/2. So I know it has to come down somewhere and up. And the only thing that remains is I need to know the coordinates, the x-coordinate of this point where they intersect. Looking at it, I'm going to guess it's 2. But let's solve it to go ahead and be sure. So we'll set the two equations equal to each other. X plus 2 equals x squared plus x minus 2. This is nice. Those x's are going to cancel out. And I'll subtract the 2 across, so I'm going to get negative 4. And sure enough, that means x is plus or minus 2. So indeed, this is x equals 2. So I'm going to be going, and this one was negative 2 where they cross there. Going from negative 2 to 2. Let's erase some of this stuff so I have room to work. So this entire region is bounded by the upper function of x plus 2 minus the lower function, which is x squared plus x minus 2. We'll make sure and put all that in parentheses. This is with respect to x. We're going from negative 2 to 2. So upper function minus lower function. And then before I integrate, I'm going to simplify it to make it a little easier. So I've got x minus x, so those are actually going to cancel. I'm going to have negative x squared. I'm going to have, well here, let's change these signs. And then it's more obvious, those cancel. And then I've got 2 plus 2. So I've got that. Then when we integrate, we're going to get negative x to the third over 3 plus 4x, and we're going to evaluate from negative 2 to 2. So if I plug 2 in there, because I always plug the upper one in first, negative 8 thirds plus 4 times 2 is 8, minus parenthesis, plugging in negative 2. Negative 2 cubed is negative 8, but there's a negative in front, so it's positive 8 thirds. Plug negative 2 in there, that's negative 8. Then I'm going to distribute my negatives, so change this to a plus, negate those. It pays to go carefully on these and not try to rush. It's really easy to make mistakes in this math with all these fractions, so I'm kind of methodically trying to go very carefully. Negative 8 thirds minus 8 thirds is negative 16 thirds. 8 plus 8 is 16. Now I'm going to get a common denominator of 3. 16 times 3 is 48. So I get negative 16 thirds plus 48 thirds. That's going to be 32 thirds. And that's the area, so it's units squared. Yeah, it's well known that this simple math here is where you're going to make the mistakes, most likely. And just there's a lot of negatives to pay attention to, so if you have to do these by hand, you need to be careful. Work through them somewhat slowly. And then that brings us to our final example, example 6. Find the area of the region. I'm not saving time on my handwriting. Contained by f of x, which is x cubed plus 2x squared minus 3x, and the x-axis. So again, let's pretend, or let's assume actually, that you have to do this by hand. And so we have to graph it. It's a cubic, and it's a positive leading coefficient, so I know it looks something like this based on the end behavior. I need to find the zeros, which actually aren't going to be too bad because I'm going to be able to factor an x out. So I'm going to go ahead and just do that. I'm going to factor an x out, x squared plus 2x minus 3. So I'll come down and I'll factor the right-hand side, 2 sets of parentheses. That's going to be positive 3 and negative 1, because that'll add to positive 2. So x equals 0, negative 3, and positive 1. So at negative 3 we have a 0, at 0 we have a 0, and at 1 we have a 0. And I know that my end behavior looks like this up here, so I can go up, down, up, like that. And that's all I need. I don't need any more specifics than that. That's enough to see that I have a positive region here and a negative one here. So this is a situation where we actually have to write 2 integrals. We have to do them separately when we're doing them by hand. So the first one, we're going to have the integral from negative 3 to 0 of the function on top, which is x cubed plus 2x squared minus 3x dx. Actually, we're going to do it all in one. Well, you could. Whatever. Anyway, so this upper function, and then the other area down here is going to be negative, and I want it to be a positive, so I'm going to have to negate that one from 0 to 1 of that same function, 3x dx. And now we get to go through and crunch all the numbers. That's the tedious part, and the part where we have to be careful so we don't make mistakes. So I'm going to go to a new color. What do I want? How about, well, I don't really like brown. I like blue. Okay, so let's integrate. We've got x to the, oh, yuck. X to the 4th over 4 plus 2x to the 3rd over 3 minus 3x squared over 2. And we're going to integrate that from negative 3 to 0. I'm going to try to go very methodically. So I'm going to be plugging in 0 first. All of these are going to be 0. So 0. And then minus, parenthesis. Then I'm going to plug negative 3 in everywhere. So I'm going to have negative 3 to the 4th. That's positive 81 over 4. Plus, I'm going to have negative 3 cubed, which is negative 27. Negative 27 times 2 is, I want to say 54. Okay, negative 54. This is actually negative. Whoa. Negative. See, I just want to be really careful here. Make sure I don't make mistakes. Then I'm going to have negative 3 squared, which is positive 9. 9 times negative 3 is negative 27 over 2. Okay, that's my first integral. So I happen to notice, see if I'd have to get a common denominator of 12, or yeah, 12. But if you look here, 54 divided by 3. 3 goes into 54 because 6 goes into 54. So 54 divided by 3 is 18. I'll admit I am using my calculator to do this simple math. 81 fourths plus 8, or no, it's minus. Minus 18 minus 27 halves. I am doing this the slow way, like by hand. I know it's tedious. Over 1. Now we can get a common denominator of 4. So, negative 81/4, 18 times 4, I'm going to use my calculator so I don't make any mistakes, minus 72/4, and then 27 times 2 is 54. So 81 minus 72 minus 54 is negative 45/4. And there is that negative out front still. So negative, negative. So we're going to end up with 45/4 for this area right here. Okay, now we have to do the integral from 0 to 1. So I have to erase a little. It's going to be the same antiderivative. What I'll do is I'm going to erase all this work and change these limits. So right now I'm just going to find the integral from 0 to 1. It's the same antiderivative. So again, I'm going to methodically, carefully go through this. This one won't be as bad because 1 and 0 are easier to work with. So 1 to the 4th is 1 over 4, 1 cubed, so 2/3. Plug 1 in, 3/2. I have lunch next, so it's okay. Plug, okay, just checking my math. And then if you plug 0 in, thankfully, it's just going to be 0. So now none of these reduce. So we're going to have to get a common denominator of 12. So multiply by 3, multiply by 4, multiply by 6. This is plus, this is minus. 3 plus 8 is 11. That's going to be negative 7/12. And then, so this is, of course it's minus that. So we're going to be adding 45/4 and 7/12. That means I have to get a common denominator here. Sorry about the background noise. 45 times 3. 135/12 plus 7/12 is 142/12. And I'm going to divide that. 11.83 repeating. I think that's 7/8, isn't it? 7 divided by 8. Oh no, that's not 7/8. I'll just look at my notes and see what it was. 5/6. 5 divided by 6, yeah, is 0.83. So this is 11 and 5/6. And that's, again, that's area, so that's units squared. Okay. Oh, so anyway, that concludes the lesson. And, and then the calculator part I think we did in class already. I'm going to have to close though, so we'll see you guys later.